Hello everybody, this is Zaxter99. Welcome back to Beginner's Guide to Learning C++. Kind of getting started with C++ so that eventually, hopefully, you can start making your own games, applications, whatever it is that you're wanting to use C++ for. Zaxter99. So in the first video that I made, we actually went and acquired, hopefully you acquired CodeBlocks. If not, you'll need to go back and visit video number 1 if you don't have a IDE, which is an integrated development environment. Now, I chose CodeBlocks because it has a great reputation, a lot of high reviews, and it's completely free and open source. So what we're going to do here is I believe we already had started a project in the last video, but I already deleted mine, so I'm going to go ahead and create a new project. If you haven't deleted that folder, you can go ahead and open an existing project right here, or maybe you already still have it open. And we're going to go ahead and create a new project and do a console application here. Here we're going to go ahead and choose C++. We're going to go ahead and call this project my first C++ program, because this video series is directed at people that are completely new to C++ or maybe have never even written a program even in BASIC or any kind of language themselves. So obviously anybody can watch this, and hopefully anybody that does watch it will learn something from this video series, and that's certainly my hope in this. So after that, we're going to go ahead and leave this. You can put this file name anywhere. You can choose to put your folder or your project anywhere you want. Here I've choose my desktop, and I would encourage you to put it right on your desktop as well so they don't get hidden away behind your documents or some weird place in your computer. I'd like to put it on my desktop so I know it's there, and then when I'm done with it I can easily find it and delete it once I'm done with that particular project. And if you watch my series, if I continue to make these video series, then we'll have several projects, and once you're done with them, you'll probably want to go ahead and delete them. I mean, if you want to redo them, you can always go back and, re-enter the data or re-watch the video. So we're going to go ahead and just choose a desktop here, as I got right here, and we're going to go ahead and hit next. Here we're going to go ahead and leave this alone. This is just basically telling C++ what kind of compiler it's going to use. There's a lot of them that it can be using, but we are going to want to compile our code into machine code that the computer is going to understand. Okay. And then we're going to go ahead and hit finish here. And we'll see that what happens here is in CodeBlocks, we've got the name of our program right over here, my first C++ program. It's also right up here at the top, and the version of CodeBlocks that you're actually using. Now, if we'll see in sources under our C++ program, that's all the sources that are included in our program. And if we click this little plus arrow, we will see that we have a main CPP, which is the CPP is an abbreviation that stands for it's a standard abbreviation that we use for all C++ programs, and the CPP stands for C++. Okay, so we're going to go in here and we're going to see that CodeBlocks has actually started again and gave us our first hello world code. What I want you guys to do is I want you to go ahead and highlight all this, and I want you to go ahead and hit your delete key on your keyboard to erase it all. And the reason I want you to do that is because we're going to be rewriting a lot of this same code, but I want you guys to start becoming more familiar with writing this code, because especially these first two lines, you're going to be using these first two lines that we type over and over and over again every time you write your own C++ program, and you're going to be seeing a lot. So the more times that you actually type it out yourself and see it yourself, the more familiar you're going to get with it. And you'd be surprised at how much that actually helps you learn the language, because if you are completely new to C++, I know that these codes are going to look completely weird to you, and you're like, what the heck does that mean? And I hope to give you some kind of explanation of that as well. I do want to go ahead and explain that, and I want to go ahead and tell you guys, first of all, before we even get started, congratulations on choosing the video series or choosing C++, hopefully as your first programming language that you've learned. You may be like me, and maybe you've already learned other languages like BASIC. And if you have, moving to C++ can be a little bit daunting. And the good thing is, if you're choosing C++, if you're choosing my video series as your first programming language, I want to give you a big congratulations and tell you you're very wise, because when I first started like 4 years ago, I had grown up with a Commodore 64 back in the 80s, and I was familiar with the basic programming language on that Commodore 64. So when I decided to get back into programming and, just a few years ago and try to relearn it, the only thing I was familiar with was a basic programming language from an old computer, an old home computer with a Commodore so many years ago. And so I went and I searched for basic programming language, and it looked like the best thing I could find that was like that was there's one thing called QBasic, and I think it's free, but I actually chose a Dark Basic, which promised to be a powerful program that would basically compile, its own set of basic commands into, your own games. And it had a pretty unique set of really powerful commands that, could take hundreds of different commands and put them into a single command. And it looked pretty impressive when I looked at it. And it is pretty impressive. The problem with programs like Dark Basic and stuff like that is that you're limiting yourself every time you choose one. Even a great program like GameMaker, which I've recently found about a year ago and acquired. Really nice for making games. It's very, very powerful. But anytime you choose something like that, you have more limitations than if you actually just choose something like C++, which is a very, very widely known programming language. Now, C++, I just want to go ahead and let you know, is a programming language that was adapted from the first programming language called C that was actually implemented on the Unix operating system way back in like somewhere between 1969 and 1972, the early 70s. It's a very flexible programming language that remains super popular today. And C++ was actually developed at the AT&T Bell Labs in New Jersey sometime between 1983 and 1985. And what it did is it enhanced the original C language by giving it more features and allowed it to transform the procedural nature of C into an object-oriented programming language of C++. So it's bigger and better than C was. It's been around since the early 1980s. And the good thing about this is, to put it in terms you might understand, to put it into clothing. We've all known that there's been all kinds of clothing or pants, let's say pants for example, that go in and out of style. Bell bottoms, for example, or corduroy pants. If you know what I'm talking about there, you know how quickly they might go in and out of fashion. And then there's always like the parachute pants and, different designs with jeans that come and go and fade quickly. Okay, and that's kind of how I see some of these other game development software, other programming languages that people learn. So, like for example, Dark Basic right now, I don't want to put it down too much, but trying to program in Dark Basic now and trying to program a really fast action game is really difficult in Dark Basic because it's so old and because there's still a lot of bugs and loopholes and memory leaks and everything else in the Dark Basic environment. And it's really not practical to go and try to learn that now in the year 2015 or whatever year you're watching this video in. So C++, if you look at it in the clothing world, would be like Levi's. Just basic your Levi 501 jeans. They're going to be cool. They're going to be popular no matter what. I don't think they're ever going to go out of fashion. So if you look at C++, it's kind of like that. You are learning, the most versatile, most widely used programming language out there. It's used to program, it's used to code everything from Macs to Windows machines to it's used in coding for PlayStation consoles, for Xbox consoles, all kinds of smaller electronic devices for robotics, just super widely used. So you have, by learning C++, you are learning a very versatile language. It's just kind of getting your head wrapped around some of the commands and stuff like that and getting into it. So I wanted to say congratulations on that. I know I blabbed a lot in my first video, and I just want to go ahead and say congratulations again because I think C++ is what I should have started with 4 years ago, and now I'm just finding myself barely getting into it. While I have a lot of the basic ideas of how to program and stuff like that from the other languages, C++ is a lot different. So we're going to go ahead and jump into this, and we're going to go ahead and program our first little program. And that's why I called this my first C++ program. Okay, so we're going to go ahead and jump into this, and I want to go ahead and start typing in our first commands ever. And I want you guys to go ahead and follow along with me or type along with me, however you prefer to do it, in your IDE or your code blocks if you've got a code blocks just like I did. And our first command is going to be a command that we're going to use all the time and that you're going to see is over and over and over again. And you want to go ahead and familiarize yourself with this. You want to go ahead and hit the pound sign, the number sign, and then you're going to go ahead and go include, and then you're going to use the left arrow, and then IO stream, and then the right arrow to include that IO stream in those between those arrows. You're going to go ahead and drop down by hitting enter and go to your next line, and then you're going to go ahead and type in using namespace. Notice how the code blocks is trying to help you by giving you what it is, you know, a common used term right there below. And then you're going to go ahead and type in std, and you're going to go make sure you go ahead and end this, because this is a statement. We want to go ahead and end this with a semicolon. I'll explain this in just a minute. Go ahead and drop down 2 lines now, and here we're going to go ahead and enter our first comment. We're going to go ahead and put 2 forward slashes. That's the one right by your bottom shift key on most keyboards. Your bottom right shift key, it's right under the question mark. And you're going to go ahead and type in whatever you want. You can put whatever you want in here. I'm going to go ahead and say this is my first ever C++ program. Okay, and I can go ahead and put 20 exclamation points if I want. It doesn't really matter. We're going to go ahead and drop down a couple more lines. I want you to go ahead and type INT. That stands for integer. And then we're going to go ahead and write main. This is also something you're going to see in almost every C++ program that you ever type. And you're going to have open parentheses, close parentheses, just like that. As we get more advanced, you may be including things inside the parentheses, but we don't need to include anything in there right now. And then at that point, you're going to go ahead and drop down. You're going to need to go ahead and do the open swirly bracket. That is the square brackets right above the square brackets. These keys are right to the right of your P button on your keyboard. And you see that when we enter our first swirly bracket, it's going to automatically put another one to close it down below, if you see that. And it's right here. Okay, so go ahead and hit the enter key a couple of times to go ahead and give you some space here. This is the body of our main function. We call this a function, and it's looking for an integer, is what this function is looking for to actually end the function. So what we're going to do is we're going to go ahead and write our main function in here, and just go ahead and come up towards the top just a little bit, and we're going to go ahead and type in the strange word COUT, and then we're going to go ahead and do a couple of left signs, making it's called a left sign when you do 2 of them together. And then you're going to go ahead and type a quotation mark. And then once you notice we do that first quotation mark, Code Blocks is going to put the second one there for you, because you always have to have a second quotation mark if you start one. It's kind of like the parentheses, for example. And we're going to go ahead and say, instead of hello world, which is so common with these first programs for everybody, we're going to go ahead and be different. We're going to be rebels. We're going to go ahead and say, yay, this is my first C++ program. Woohoo! Okay, and notice that quotation mark is already closed for us. Code Blocks put that in for you, so make sure you don't delete that. Instead, just go ahead and right arrow past that. Okay, and then put a space. And then again, we're going to go ahead and do 2 left signs again. And then we're going to go ahead and type the command ENDL, and then go ahead and do a semicolon to end this statement. Okay. And then after that, we're going to go ahead and drop down one more, and we're going to go ahead and type the command return 0, and then again a semicolon to end that statement. At this point, we've actually typed almost the same thing as we had in here when we opened Code Blocks, except that we've changed exactly what it said, and we've also made a notation remark. Okay, I want to go ahead and explain to you what this does real quick before we actually compile and run this. Okay, so the first command is an include command, okay, and it always starts off with the number or the pound sign there, and then we're telling it what to include. And by putting this command, what we're telling Code Blocks to do, what we're telling it to do when it compiles, is we're telling it to, hey, include, there's a library of useful commands and resources that have already been programmed for us to give us certain commands to make our life easier when we start coding in C++. And so by doing this, this is open source commands. This is included in the IOStream is included in the C++ programming language already, but to call these commands, we actually have to include this at the start of our code. Okay, so this is required so that we can actually use input and output commands, and that's what IO stands for there, is input output. So include the input output commands for us in our code so that we don't actually have to go in and type all that stuff ourselves. Saves us a lot of time and trouble by using universal open source libraries that are already out there. And there are tons of different libraries that are open source already that are going to make your life a lot easier when you start getting into C++. You don't have to code absolutely everything out there when there's, functions and little pieces of program that do a lot of common things that work in a lot of common programs and games already. Why would everybody have to write their own code, for example, on, different facets of, 1,000 different games when they can simply just go and grab a library that's open source, it's free to use, it's available for anybody to use, and you can actually include those resources in your own C++ program. And that's the great thing about using the C++ language, because you have so much open source library already available to you. It's going to make your programming a lot easier. Okay, so that's all I'm going to go into that for now. Okay, the next line here is going to be using namespace std. What this actually does is it's basically telling us that we're actually going to use this function std, and this line is telling the compiler that instead of actually having to type std before like our cout display with 2 colons, for example, if we didn't type this using space std, if that wasn't here, we would actually have to come down here on every time we put some output to the screen, and we would actually have to go std and do a double colon like that. Okay, and so you can imagine if we had a much longer program, every time we put C input or C in or took input to the program or whatever, instead of having to type that std in 2 colons, now we make our life easier by not having to do that. We can just simply go with the cout right here. So that's why that's there, and it's a very good practice to go ahead and get into, because you will probably see these first 2 lines in almost every C++ program you ever do, okay, or that you ever look at. The next line, besides our note here, this is a notation. Anytime we actually put 2 forward brackets, which is again the slash, that's why I call that a forward slash, because if you look, it's actually pointing forward from the start of the character. So from the start of the character, the slash is a forward slash because it points forward. For example, this is what I call a backslash, okay? Because it looks like the slash is falling back or backwards, all right? So 2 forward slashes basically tells the machine or the compiler, when it compiles this, to ignore anything after those 2 slashes completely. And that's why you kind of see it faded a little bit here in code blocks. So this is just a note to yourself or to anybody else that might look at your code later on that tries to help you debug, or if you have you and a friend are starting to make a game, 5 years from now, maybe you get a programming buddy like you and you decide to work on some big game or whatever, and you guys are both working on different functions of your game. Like, say, for example, you take, you take the one part of the game, like character movement and graphics and this and that, while your friend is actually working on, building the world and building collision data and stuff like that in the world that you guys are going to be playing in. So you guys have decided to break up the code so that you're both working on part of the same game. Well, when you actually integrate it all, and you actually integrate your friend's part of the code into yours, so it's one big program, if he has his program well coded, you're going to easily understand what he's doing. So if he gets sick or he stops working with you or whatever, and you've already combined it, if he doesn't have everything coded, or commented rather, with his comment statements, you may actually be completely lost when you actually look at his code as, what is he trying to do here? But if he says, hey, this is the command I'm using to do this, and down here I have this function is doing this, and you go, oh, okay, I see what he was trying to do, because he's explained it here, hopefully in English that you can understand a little bit better than some of this. So it can also be useful to yourself if you go back and try to debug a really long program that's hundreds of thousands of lines long, so you're not it can help you easily find a certain part of your program that you need to debug, for example. So comments are very good practice to actually get into. So the more comments, the better. It doesn't slow down your game at all or anything like that. Again, the compiler is just going to completely ignore not only your comments, but it's also going to ignore all this white space here. All the white space is going to be completely ignored, and all this is just going to be changed into a machine language, just the stuff that it wants, okay, that the machine can use. So the next line here is going to be the int main. You're going to see this every time that you run C++ or look at a C++ program. You're going to see a main, and this basically is saying that this is the main function. Every C++ program has to have at least one main function. You may find bigger C++ programs that have hundreds or thousands of different functions, each function doing its own little thing, and it breaks it up into easier tasks. So if you can imagine, yourself, if I tell you to go build me a barn, and I just give you a hammer and nails and wood and tell you to do it by yourself, that would be a daunting task. To go and just by yourself, look at yourself as being just one function. If I tell you to go build that barn by yourself, that's going to be a lot for you to take on by yourself. But if I give you 30 other people to help you out, and one person is, sorting the nails, and another person is sawing up the wood, and another person is working on the windows, and another person is working on the floor, for example, and so forth, now you can break it up to 30 different people, or 30 different functions in this example, and you're going to simplify the barn building task. Same thing here. When you're making a big complex game, rather than trying to put everything in this one very complex function, you can simply break it up into different tasks. So one function might be printing the score on a game. One function might be, getting character input from the keyboard. Another function might be, updating the graphics, and another function might be, playing any sounds. Another function might be checking for collision to check if your character's collided with other objects in the game, and so forth. So you break it up into different functions, and then you can call any function at any different time. Another reason for functions as well is, if we have our main function and we're sitting here trying to write it all in one function, right? And then we're going through our game and we have to update, let's say we have to have, say we have 5 lives. Let's just keep it simple here. Let's say our character has 5 lives, and every time he dies, we've wrote 100 different lines of code to make our character vanish and disappear, or make our character blow up into pieces, right? Really looks really cool when your character blows up into pieces because he's died. Blood and everything, right? So you've sat here and wrote 100 or 200 lines of code just to make your character blow up, okay? Well, why would you want to have to write those hundreds of lines of code when you've already wrote them once to make your character blow up? What you can simply do is write those 200 lines of code or whatever it is to make your character blow up, and you can put that in a separate function. And then every time you die in your game, you can simply call on that death function in your game, or whatever you call it. You can call it whatever you want, blow up function, or death function, or whatever, and you can call on that function every time you die in the game, rather than having to type those 200 lines to repeat the death every time. So hopefully that makes sense as to why you break these things up into different functions. But again, just remember right now that every C++ program has to have at least one function, and that's the main function. Also, one thing I want you to remember with functions is you can put them anywhere in your code. So for example, if I wanted to go ahead and write another function called my death function here, right? So if I wanted to go ahead and say death, right? And this is another function, okay? And then I go ahead and give it my swirly brackets, and in here I got all my code. And imagine this be, tons of lines of code right here. Obviously this doesn't make any sense. I'm just typing out to give you the idea. So when your game actually compiles and your game actually runs, when you run this command, what it's going to do is first of all, it's going to include any libraries and attach any files or resources with this IO stream or anything that you've included first. It's going to include that. It's going to say, okay, he's using the namespace std, so he can avoid typing all that out. It saves me, a lot of typing out stds and the double marks and all these different commands. So it's going to look at those first so it knows what you're doing. And this is what you call your header file, your header lines. So it's going to do that first, but then it's going to look for the first function. The very first function it's going to look for is your main. So it's going to jump right to main. So even if I have 50 functions before my main function, the way I've written my code, it doesn't matter. It's going to ignore this remark, all these comments you have. It's going to completely skip over those. It's going to skip over any functions that aren't your main. It's going to immediately look for your main function first, and then when this function death is called, when we call the death function somewhere in our program, then at that point it'll jump to this death function and do whatever that says. Okay? So hopefully that makes a little bit of sense. If it doesn't, don't worry, because the more you get used to this, the more you watch these videos, the more you play with C++, the more you're going to understand this. Okay. I want to try to keep these pretty simple, so I'm not going to get too complicated, but I'm hoping that I'm at least enlightening or turning on some light bulbs for some of you viewers out there. Please let me know down in the comments below if I'm too advanced, if I'm confusing you, or if you like how I'm explaining things, whatever it is. Please be sure you put those down in the comments below when this video is over. I would certainly appreciate that, because this is really the first time I've tried to teach anybody anything about programming or anything like that. So I'm kind of taking on a big task for myself. You know, I'm getting pretty good and pretty used to like playing games for people, but teaching somebody how to actually code is something I've certainly never done before. So we know now that this is our main function. We know now that every C++ program has to have the main function or it's not going to work. Okay, so now we look inside the brackets, and everything inside these brackets, whether it be these 2 lines or whether it be 100 lines, whatever's between this bracket and this bracket is our main function. So you can imagine as you have longer and longer programs, you can imagine these main functions are going to get bigger and bigger and more complex. All right. But this is pretty simple. We're going to go ahead and look at this first command, and you're like, what the heck does that mean, Zaxter? Well, cout basically stands for character out, and it's part of our IO stream that we called at the beginning. This would not work if we hadn't called our IO stream at the beginning. It would give us an error, and it would say it doesn't understand cout. But by including it, the include IO stream, now it knows what the cout means, and basically says, okay, I'm going to be putting characters to the screen. This left shift is required. It's basically showing you that it's wanting to put what it's given the command cout to put to the screen. So if you look at these 2 arrows, basically what you're saying is, okay, what am I going to give cout to put to the screen? Well, it's going to be whatever is after these arrows, and these arrows are basically pointing towards my cout. Okay, so in these quotation marks you can put anything you want. It's important that you put the quotation marks if you're putting text, though, or the compiler will see these words as like variables. So for example, if I didn't have these quotation marks, it would say, it would think that yay is a variable, and I actually haven't assigned a variable yet called yay, and then I would get an error. So you want to make sure that if you're putting text to the screen, you put it in these quotation marks, and then that's going to go right to your cout, okay, which is your character out. After this, I have 2 more arrows basically saying, okay, after this text that I've put in these quotation marks, I'm going to do this command. Okay, and that command is actually end. L stands for line. Okay, so end line is actually what that means. And what this does is it tells the compiler when this text actually ends, we want to go to the next line. So rather than typing whatever is our next line, whatever the computer prints out or whatever we print next somewhere in the program, rather than starting right after this exclamation point, we want to go ahead and end the line so that it starts down on the next line. That's all that does. And then remember, again, after any statement, we have to have this semicolon. Just like up after here, that's a statement. Right here, we have a statement. We have to have that semicolon. Here's another statement. We have to have that semicolon. Obviously, you don't have to have it after your remarks, and you don't have to have the semicolon after your include statement, your header include statements. Okay? So after that, the only other command we actually have is a return, and it's returning a 0. What this is basically saying is that in our function that you called up here with an integer, this is looking for an integer as a return. So we're returning a 0, which is basically saying, hey, we're done. Okay, everything ran successfully. I'm done with this function. Go ahead and move on. So the program will actually say, okay, we're done with this function. We can move on to whatever's after this if we have anything after this. Okay? So that's really all there is to this program. And And that hopefully I've explained this well enough to at least give you an idea. Again, I haven't been working with C++ for very long, guys. I could probably explain basic and dark basic a lot better, but I want to, like I say, I want to start getting into this stuff. If anybody's watching and I didn't explain something the best or whatever, please put those comments down below. Let me know what I could have explained better, and I will certainly try to get you a better explanation, or hopefully somebody can explain things better down in the comments below. All right, but I think I got the basic gist of how this works for you. And what we're going to do now is we're going to go ahead and tell CodeBlocks here to compile this first program that we've written and run it. And let's see what happens. So we're going to go ahead, if we look up here on our CodeBlocks, we'll see two different things. We see a little yellow gear here. That's the build. What this is going to do is it's going to build this program into the machine language that the computer can understand. Okay. When it does this, it's also going to look and check for any errors. So if it finds any errors, rather than building, it's going to stop what it does. It's not going to build it, and it's going to give us an error down here and tell us what kind of error it was. Okay. And then after this, if we build it, we have a run. This would be to simply run our program as it is without building it. If we just click that right by itself, it wouldn't build it. It wouldn't do anything. It would just simply try to run our program in machine language, but it wouldn't build it. It wouldn't build an executable file or anything like that. And here we see a nice convenient command that actually builds it and runs it. So this is the one that I actually like to use. Now before we actually build and run this, I want you to check out one other thing here in CodeBlocks. If you look right here before our main CPP part, or source of our code, of our program, we actually have a little asterisk right here before the main. And what that asterisk means is that whatever we've typed here, we've made changes or we've typed out data here that is not saved yet. So that's a good thing to remember. So if you've made a change or you've done something to your code and you haven't saved it yet, you're going to see that little asterisk. So that's probably a good indicator to save. And it's always a good idea when you're writing codes like this to actually save often, so that, just in case the power goes out or in case your computer crashes or something goes wrong, you won't lose hours worth of work. Okay? And you can always save it by either going to File and you can save your file, or you can simply just go ahead and build it or run it, or just build it, and that will save it as well. So let's go ahead and build and run our program and save it and look for errors and see if it even runs. So let's go ahead and click that build and run now. We'll see that now the asterisk has went away. Down here it actually compiled it into an executable file, and it started executing the file as well since we chose build and run. So the first thing it did was it checked for the existence of it, and it built it, and then the executable file, and then it executed the program because we chose build and run. And we see that right up here it actually displayed just what we told it to. Character out to the screen. Yay, this is my first C++ program. Woohoo. Yay, this is my first C++ program. Woohoo, is right here on the screen. And then this is just stuff that's given to us by CodeBlocks. It's basically telling us how long it took to actually run this program, etc. And then built into CodeBlocks is actually a little feature that'll say press any key to continue. Now this is not included in the code that I wrote. It's actually built into the CodeBlock integrated development environment. Now some compilers or some IDEs that you program in will not have this built in, and when you type this exactly the same way, what'll happen is this will come up and it'll work, and you won't get any errors or anything like that, but it'll say, yay, this is the first program, whatever you set it to say, and then this whole black thing will go away. So I'll show you exactly what that looks like sometimes, but this is a nice little feature built into CodeBlocks. So we can just go ahead and X out of that now, and it'll tell us our, our build log and stuff like that down here. Okay. But what I wanted to show you guys now is, first thing I want to do is, if you got the same black little screen and you got your message to come up on that DOS window, that the command window that popped up there, I want to go ahead and give you a big applaud. I want to go ahead and say congratulations on typing your first C++ program, if that's indeed the case. Maybe this is the first program you've ever written. This is not something light. This is not something to take lightly. This is actually really, really awesome, because how many people out there do you think actually take the initiative, take the actually get up the nerve to look it up on YouTube or look up resources and actually look up a video on how to write in C++? And if this truly is your first C++ program, I mean, be proud, be happy of that, because there's not a whole lot of people, you know, if you look at percentages of people out there that have actually programmed any C++ program, you're in the slim margin there of people that have actually done that. So congratulations to you. There are, you know, probably well over 90% of the people out there on Earth at this point right now have never programmed a C++ program or any program at all. And now you've taken your first big step, and the first step is always the most important. So again, congratulations to you. So what I want to show you guys real quick here is, remember how we actually saved our project in a folder right on our desktop. That's where I chose to save my folder. So if you saved your folder right on the desktop as well, you should see your first C++ program, or whatever you called it, right here in this folder. If you go ahead and double click that folder, right, here is your source file that it built. Here is your project file that you're using for code blocks. This is your project file that code blocks recognizes. Okay, and then here is another object file folder for debugging that your code blocks uses when it compiles your code. And then inside your project folder as well, you're going to see this little bin folder. If you double click on that and you see in your debug folder, it's been successfully debugged because it's in that folder, you will see your actual executable file. And that is a file that you could actually email or send to your friend or to your mother or to your, you know, whoever, and say, look, I programmed my first C++ program, right? So you could actually right click that, copy that, and let's go ahead and paste it on our desktop. Let's go ahead and take that executable file and post it right on our desktop. That is your first program. Okay, if you right click on this and go down to properties, I want you to take a look at this. This is an actual executable file, okay, which means it's going to run in almost any Windows computer out there. Windows environments are going to, you know, because we got the code blocks for Windows, it's going to actually compile your data here into a Windows executable file that Windows computers can actually run. So if you're using Linux or whatever, for example, then the Linux version of code blocks would compile it into a executable file that Linux computers could run. I don't know anything about Linux, but it's going to compile a program that Linux computers could run. Okay, but another thing I want to show you is, look at all these different games that I got on my computer. You can see I got a lot of different games. But let's take a popular one like Minecraft, right? Let's go ahead and click on the properties for that just to show you. And if I click on the properties for Minecraft, look at this type of file. It's an executable file. And, you know, this guy made this Minecraft game. He charges like $26.95 for it. He's gotten rich off of it. And that is an executable file. You've also made your very own first executable file in C++, the most versatile and most popular and well-recognized programming language. So this does mean a lot more than you might think it does. This is really cool, and this is a moment to celebrate. So again, I want to go ahead and congratulate you on that. Now I want to go ahead and show you something else here too. Remember that when we ran this program, if we run this program again, right, remember that it actually shows what we displayed, and then it says press any key to continue. Remember that I told you that press any key to continue is part of the built-in feature of code blocks, and that if you wasn't running in code blocks, if you was running it, for example, in maybe a different IDE, if you type this into a different IDE, you might just simply see this flash up before you could even read what you typed here. So to show you that, let's go ahead and run this executable file that we built, right, that our compiler built for us. Let's go ahead and double click this to run our file, run our program, see what happens. Did you see that? If I do it again, bam, it comes up so quick I can't even read it, and it disappears. The reason it does that is because if we take a look back at our code, after we actually have the character out to display what we've typed here, we end the line, okay, and then we simply return a 0, which basically says, okay, we're done with this function, and then after that there's nothing. So there's nothing here to tell the computer to stop, okay? There's nothing here to tell it to wait for us to type something. There's nothing here to tell the computer to do anything, so it basically closes it out because it's done with this program. It's trying to complete this stuff as quickly as it can. So it goes through all these tasks and does everything that we've said in machine code, and then it's done because we haven't told it to stop. We haven't told it to sit there and display that for an hour for us to look at, anything. So that's what we're going to get into next in the next video, is we're going to actually make something where we can actually input things, and where, when we actually run it, it'll actually stay up here on the screen and we can actually do more with it besides just read one line. But I do want to go ahead and say congratulations again if you followed me along and you've made your first C++ program. It is definitely your first steps. It's a big moment. And I also want to go ahead and encourage you guys to, if you're excited about this, if this makes you feel good, to actually make your first C++ program. If you're really interested in programming in C++, look for, other sources out there, because other people on YouTube, other people, if you take a class on C++, if you read a book or whatever, again, this is the first time I've ever tried to teach anybody how to program in C++. So there are probably a lot of different people that may be better at explaining things, especially to different people. Some people learn things better from a certain type of person or a certain style of teacher or whatever. So, don't be afraid to go out there and venture or look at websites. There's tons of websites on how to program C++ and all kinds of good stuff out there available to you. A lot of it is free to use. You can look at forums. There's all kinds of great stuff. Now, one thing I want to go ahead and do is, I want to go ahead, before I end this video, is I want to go ahead and look at something, and I want to go ahead and turn this executable file that flashes before our eyes, and I want to go ahead and make this executable file say also press a key to continue. So I want to be able to see what we've typed on the screen with our executable file, and I want to help you guys do that before I actually end this video. So I'm going to go ahead and delete this. That I remember I copied it and just pasted it out to my desktop. So I'm going to go ahead and delete this now. And what I'm going to do is I'm going to go ahead and just add a couple more commands that are going to help us do just this. Okay. So I'm going to come back in here to my command, and remember, look how we've saved it and we've built this last thing we did. So there is no asterisk right here before main. So I'm going to come back in here and I'm going to start making some changes. I'm going to go right after here and I'm going to include another include command. So I'm going to go ahead and type include, and I'm going to include another open source library, and CST, and then D, and then LIB stands for library, I believe. And then we're going to go ahead and close that. And then after the C out, I'm going to go ahead and tab over here. I'm going to go ahead and tab over here to the next line, and I'm going to go ahead and type the word system, and then I'm going to go ahead and open parentheses, and then I'm going to go ahead and put in a quotation mark, and then I'm going to go ahead and type in all caps, pause, and then I'm going to go ahead and make sure that after that last parentheses I put a end line, semicolon here, and hopefully I've typed this correct. And after this I'm going to go ahead and enter a line so that I got my return down here by itself, and that's exactly what I want. And hopefully this will actually build and compile correctly, and we'll have no errors. So we're going to go ahead and notice how we have the asterisk here saying that we've made changes and we haven't saved it, so we do need to go ahead and save it. So I'm going to go ahead and build and run it again. Okay. So now we notice that when we display this, again, we have our press any key to continue, but remember how this is built into code blocks. So nothing's really changed. It's just saying press any key to continue. We press a key, and actually it has changed, because now it's saying the rest of the stuff that code blocks has given us, how long it took us to run, how long this program was running. So for example, you noticed that this is 13.4 seconds. That's because we sat here and looked at it for 13.4 seconds before we ended it. And all this is stuff that is given to us by code blocks. Process returned 0. That's coming from a return right here, I believe. And then the execution time was how long this program ran before we actually ended. Because once we actually, what the system pause does here is it actually pauses, it causes the machine to actually pause. It's part of the CST lead library here. And it causes the system to pause until you actually press a key. And that's why it says press a key to continue here. And this is all built into the system pause command, which is part of the CST library. Okay, so that is what's there. So once we actually do that, which is right here in our program, then the game is done. And remember, all this press any key to continue is part of the code blocks putting that in for us. So let's go ahead and close out of this. And now let's go back into our folder again. Let's go back into our binary and look at our newest version of my C++ program. Let's go ahead and copy that and paste it over here. Double click it. And now we notice that it doesn't flash and go away before we can even see it. Now it simply just says press any key to continue. So once I press any key, it doesn't matter what key it is, now it disappears. So by including this library here, which gives us use of the system pause command, I've actually been able to make it so I can actually see it when I make that executable for my friend to run. So here we go here. One thing I want to do though is I want to change one other thing before we actually wrap this video up, and I want to show you a couple of things actually. But notice here, I don't want this press any key to continue, which is part of my system pause command. I want this to drop down a couple of lines so that it's not like so close to whatever I've typed up here. I mean, this epic line that I've typed here, yay, this is my first C++ program, woohoo. You know, I mean, look at this press any key to continue. It's like up in its bubble. It's like interfering with it, and this is not nearly as cool as if I got this down out of the way a little bit so that it's not all trying to steal the impact from my amazing line here. This press any key to continue is just stealing the impact of my great program here. So what we're going to do is we're going to simply go ahead and delete this again, and we're going to go ahead and try to change our program so that line is dropped down a couple of spots. Also want to show you another little shortcut that you can actually use as well. So you notice here that we actually had before, we typed in our line here, and we also typed in two more left arrows to go to our C out, and then we typed in that end L, or that end line command. So what I want to do now is I want to go ahead and erase this end line, and I want to go ahead and erase those two left arrows. I want to show you a quicker, easier way to do this. Okay? Remember, we're still going to have our semicolon if we're done. But we're simply going to put something right before that end quotation mark here. And we're actually going to use the backslash. Remember, the backslash is right above your enter key on most keyboards. It's not the one we was using up here for our comment. So we're going to use the backslash here, and we're simply going to put the letter in. Okay? And then that will actually do the same thing as inline. It'll drop it down one line. But if we actually use the backslash in again, that'll give us another line drop. And if we use the backslash again, it'll give us another line drop. So this makes it really simple. So we'll just go ahead and use this, and I'll show you what this does. So here again, we've noticed a change. So we notice our star here saying, hey, you've made changes since you've last saved it. So we're going to go ahead and save, build, and run our program again. And here now we see that our basic program by itself drops the first slash in, drops it down here, right under the Y. The next slash in drops it down one more line, and then the last slash in there drops it down a third line before it says that press any key to continue. And now you see that our epic line here, yay, this is my first C+ program, woohoo, is not, it stands out all by itself, and it looks much more awesome and epic because it's not being interfered with by this press any key to continue. So I'm trying to be a little bit comical, hopefully at least made somebody out there smile or laugh. So that is pretty much it. I do want to go ahead and, if I was to go ahead and grab this executable now here, it's going to be exactly the same thing. Okay, so I can go ahead and copy this, I can paste it, and I'll see that I've got the exact same thing in my executable file. I can send this to my mother and say, look at my first C++ program, or my friend, or whoever, right? So imagine this as how cool. Now you may think that this isn't that impressive, but actually it is. Because think of it like this. What if you have a friend or your boyfriend or whoever it is, your girlfriend out there, right? How many people out there can simply type an email? You know, everybody does email, right? Okay? Everybody out there simply types an email when they want to type to their girlfriend or their friend or whatever, and they send an email. Imagine how much cooler it would be for you to send your significant other or your friend or your mother or whatever an actual program that you wrote that says what you want to say in an email. So my challenge to you is, if you're thinking about writing somebody in an email or whatever, instead put whatever you're going to say into this program. Obviously you'll have to actually have more C outlines here. And I would encourage you to like break this down into sentences or whatever and use several C out commands. Every time you want to do a paragraph, just use a couple of these backslash ins. And if you want to type a couple of paragraph email to your mother or to your friend or to your boyfriend or whatever, instead make an executable program that you can attach to an email and send them, okay? See if they trust you enough to to believe that you're not sending them a virus, right? And see if they'll actually be able to go ahead and download your program and actually have a black box pop up, which is going to look a lot different than just opening an email. And you can say, look, that's an executable program. This is my first C++ program. Look at what I can do. I sent you an attachment. Now you have it on your desktop, and you can simply read it anytime you want. So there's a good challenge if you want to make something a little more advanced, and if you want to venture out and do something yourself a little bit and play with C++. That would be a very good first what's the word I'm looking for? First objective, first task, first adventure in C++ is writing an email with a or writing a program rather, a C++ program that'll run on any Windows computer instead of writing an email. And just type whatever you want to say in several cout commands here. Obviously you want to test it yourself and make sure it works good, make sure everything's spelled right so you don't look like a buffoon, because that's probably what I would do, is spell everything completely wrong. I am very good at Typanese, so that's that. So hopefully you guys are getting a good idea of the basics idea of C++, and you're getting a little bit of understanding for at least a little bit. Hopefully you know what cout means right now. Hopefully you know what these 2 forward slashes means by now. Hopefully you know that you're probably going to see include IOStream and this using namespace std in almost every C++ program that you ever see or code from this point on, and that every C++ program actually needs to have a main function, and that more advanced programs may actually have several functions that are called upon throughout the game whenever they're needed. So if you have understood that and you do kind of understand the gist of this video, then you are taking your first big step into C++, into basic programming, and to having an understanding of how this all works and ties into the game making process, into C++, into writing code, and how computers actually turn this into machine code that it can understand in an executable file. So in our next video, we'll actually be getting into a lot more. We'll actually be getting into some variables and show you what kind of variables are understood in the C++ language, how programs actually use variables, different kinds of variables you can actually use, and we'll actually use variables to actually make our first game. So we'll actually, instead of just putting a simple line of text to the code, we'll actually be requiring input from the user, and we'll be putting output back, and we'll actually go and make our first game, and then we'll actually challenge ourselves to make the game more advanced and better. So where we can actually play against the computer and see if we can actually outsmart and beat the computer at our game. Okay, so we'll try to do that we'll try to at least get started with that in video number 3 of my beginner's guide to learning C++. So I want to go ahead and thank you guys for watching. Be sure you leave those comments down below if you're having any troubles or any questions or anything like that. Be sure you put those down below. I'll try to find an answer for you or help you the best I can. If you like this video, if it's helping you, please go ahead and give me a thumbs up. Let me know. If you give me a thumbs down, that's certainly okay too. But if you give me a thumbs down, don't just dislike it just to dislike it. Please tell me what would help you more, why you don't like it or whatever. And if it is that you find this is too slow, if I'm going over stuff that's too basic, you might want to be looking for somebody else that's into more advanced C++ programming, because I am really trying to target these videos at complete beginners to C++ and even people completely new to programming. So again, I want to go ahead and thank you guys for watching. This has been Zaxter99. And before I actually go, I want to go ahead and show you guys one thing. And that is, if you actually go to Google, right? Remember that second include, just one more thing to look at for you guys before I actually end this video, while you're waiting for the next video to come out. And again, I encourage you guys to actually look for C++ resources yourself. But remember how we included this cstdlib. And you were probably like, what the heck is that? Well, let's just go ahead and Google that. cstdlib. If we just Google that by itself, we'll actually see that the first thing that pops up is a C++.com reference. And this is a good site, because I wanted to go ahead and show you guys this. If I click on this, this actually shows you here that this is C++.com. This is probably a great site. I haven't even actually looked at this site yet, but I'm probably going to be looking at this site now. But it looks like a great source for you to actually go to. But the cstdlib shows you that this is the C Standard General Utilities Library. This header defines several general purpose functions, including dynamic memory management, random number generation, which is very nice, communication with the environment, integer arithmetic, searching, sorting, and converting. So as you can see, it gives us a lot of different functions that are available, and you'll see that that system pause is going to be one of those commands, one of those functions that we was actually able to pull right there. So there it is right there. So there you go. So you can actually see what some of the functions are included in that library by just simply Googling the name of that library that I included in my command. So a good place for you guys to look at, a good place for you guys to start researching and, you know, venturing out and learning more about C++, especially if you're excited about getting your hands in it. Again, we'll be back here hopefully real soon with video number 3 and get into variables and getting into making our first game. I'm going to go ahead and thank you guys again for watching. This has been Zach099. Take care, everybody. Zaxter99.